So welcome to Community Call 76. My name is Mark Fussell. I'm a Dapr maintainer. We have a thrilling setup of presenters for you today on this call. And with that, let's dive into what the agenda is. So we're going to start off with Chris diving into an exciting addition to the 110 release, which is workflows. In fact, all of this is about 110 in terms of new features coming in. Then we'll dive into Phillip Hoff, showing you how we can build pluggable components, which featured in a previous call. It allows you to build components that are external to Dapr itself. He'll show you how you build those easily with .NET. And then we'll finish up with Mukundan diving into an exciting new feature for local development, how you can run and launch multiple apps on your local development machine to improve your local development experience. Before that, I thought I'd give you a little update about where we are with 110. We are effectively coming to the end of the feature complete phase of the project, and we're entering the stabilization phase, which is, hurrah, we're getting close to our release. You can see how we do all our releases in this link here I've given in terms of our release cadence and our release milestones. So the stabilization phase is all about preparing for our release that will come out now in February. And what that means is next week, you'll see release candidates come out. So more than anything, take those release candidates, but announce each one on the Dapr Discord alias, on the announcements channel on Discord, and try them out, give us feedback, and post any questions you have on the Discord release channel that we have there in terms of feedback on features, bugs, and things like that. So with that, I will hand over to Chris. I will stop sharing and let you share, Chris.
All right, thanks, Mark. So let me use the share screen button here. And okay, I think you should see my screen now with the Dapr workflow slide. Holler if you don't. But I'm going to talk about Dapr workflow, as Mark said.
You're not sharing, Chris.
Yeah.
I'm not sharing. Okay. Oops, I clicked the screen but forgot to click share. How about that?
Yep.
Awesome.
Good.
Okay. All right. So first thing I thought I would talk about as I start my timer here to keep track of my time is why workflow? Why did we think that adding workflow to Dapr would be a good idea? Well, so what we often see is that developers often need something to orchestrate logic distributed across various microservices. And so we thought, well, why not have a feature like workflow to make something like this a bit more possible than it is today? We often use queues, cron jobs, background workers, and things like that to build these workflows, often in a very ad hoc way with various implementation quirks. And we don't realize that we're actually building a workflow behind the scenes. And so, we figure, why not make it first class? Hence workflow. And then making your code durable and reasoning about failure handling, which is often something that people use workflow systems to do. It can be very difficult for most app developers when you're sort of building these things in an ad hoc way. And so by adding workflow to Dapr, we figure we can sort of make that easy, building sort of these reliable, durable processes. And if you're not familiar with what scenarios workflows can be used with, I've listed just a small few of them that we've seen in our experience, such as things like order processing involving various microservices, such as inventory management, payment systems, shipping, etc. We see HR onboarding workflows that coordinate a bunch of tasks across multiple departments within a company, as well as human participants. We see things like orchestrating the rollout of digital menu updates in a national restaurant chains, needing to sort of be able to do that in a reliable way across multiple steps. Or looks like I have a typo here. I meant to say image processing workflows involving AI-based classification and storage. Oftentimes, those are workflows that sort of need orchestration of different systems or maybe even different cloud services that you are pulling in. And so workflows tend to be a really good fit for those. And so those are some of the types of scenarios that we're targeting with this feature. So just to give you an overview of what the feature is, you can read the detailed proposal on GitHub. It's issue 4576. But basically, it's a workflow engine that runs inside the Dapr sidecar. It also includes SDKs for authoring those workflows in code using any language that you're comfortable with, and APIs for managing those workflows, including APIs that allow you to start new instances of a workflow or query existing instances, do operations like suspending or resuming those workflows, terminating them, so on and so forth. And the idea too is that these APIs, not only can they be used for the Dapr workflows, but also for external workflow engines. So in the spirit of Dapr, which allows you to sort of plug in a lot of different component implementations, we will allow these workflow APIs to also work with external workflow engines. In fact, starting with Temporal in the very first release. I saw Dominic was on the call, so hello, Dominic, from Temporal. So anyways, yeah, the initial alpha release, as Mark mentioned already in the start of this call, this is all targeting 1.10. And in this alpha release, we're supporting .NET for both the management APIs as well as the SDKs for authoring workflows. And of course, you can still use HTTP for calling the APIs for managing workflows. We have a bunch of additional languages that we're planning for what I'm calling vNext. So including languages like Java, Python, Go. And so further down the road, we also want to add support for declarative low-code workflows, where maybe you don't want to use a programming language, but you want to use something like a designer, or you just sort of like markup like JSON or YAML. One of the schemas that we're sort of looking at supporting is potentially the serverless workflow spec, which is currently a CNCF sandbox project. But anyways, that's down the road. We're still having some discussions about that, but it's something you could potentially look forward to with Dapr workflow. So a quick overview of the architecture. One of the interesting things about this engine, there's several interesting things. One of them is that the engine itself, if you look at this Dapr sidecar container, it's embedded directly into the sidecar, and it uses the Durable Task Framework library to sort of implement this engine behind the scenes. Now, if you're familiar with that framework, it was originally written in .NET. We've created a version of that in Go, which allows it to be embedded directly in the sidecar. And then one of the neat things about this framework is that it allows you to sort of swap in and out different storage providers. And we've actually created one specifically for Dapr that leverages actors behind the scenes. Now, these are internal actors. These are not actors that run in your application, but these are actors that run inside the sidecar container. They're just an implementation detail, so nothing your app needs to worry about. But they manage things like workflow state, scale out, and concurrency. And so, for example, because we're using actors, you can actually store your workflow state in a variety of Dapr supported state stores like Redis or Cosmos DB or anything that would otherwise support actor state. Workflows will be able to leverage the exact same state storage behind the scenes. Let's see, and then sort of the main idea is if you look over to the app container on the right there, the idea is that you will write your workflow code inside of your app. You're going to be using the Dapr workflow authoring SDK, and then that's going to connect to the sidecar using this gRPC stream to sort of coordinate the execution of different parts of your workflow. All right, and with that, I think I'm going to just jump straight into a demo of this so we can see what it looks like. First thing I want to show is this is a sample application that we have written to show off how to author workflows. This is, I believe this was just merged yesterday into the .NET SDK repo, so you can go and check that out at any time. But we have a workflow web app here, which is an ASP.NET application that combines both workflow and web APIs within the same project. We could have made it into two separate projects, but we decided it might be simpler to just have a single project that you can press F5 in Visual Studio or just run from the command line super easily. So this app, it follows the basic pattern of, I create a builder, but then I have an extension method called add Dapr workflow, which allows me to sort of register workflows and what we call workflow activities, activities being the tasks that workflows can schedule. I should mention, if I quickly open up this project file, there will be a NuGet package called dapr.workflow that you add to your project to sort of get these capabilities. So you can expect that to be coming out as part of this release as well. But again, the main idea is that we're able to register workflows and register the workflow tasks. And if I jump into the definition of what is this order processing workflow, well, it's just a class that I've defined within my demo application here. It derives from a base class, which is workflow, and it takes two type parameters. One is the output of the workflow. Workflows can have outputs. Sorry, this is the input. This is the output. And so these are sort of domain models associated with my workflow. And then I have a single run async method where I put the logic of the workflow, which is going to basically call a bunch of what we call workflow activities. These are the things that do the work of the workflow. This is mostly just the orchestrator here. But for example, you could see that I'm just writing normal procedural code here. Each workflow has a context, which tells you something about the instance of the workflow you're running, including each workflow has a unique identifier associated with it. Much like actors have an identifier, workflows do as well. We just happen to be using that as the order ID. So a simple statement to just save that as this particular variable. And we can call activities. So I have a notify activity, I have a payment processing activity, and I have a reserve inventory activity as well. And so I'm just writing normal code to sort of orchestrate a sequence of execution for all of those activities. So if I take a look at an example of, well, how do you author an activity? Activities are also just a class definition. And they can take inputs, which again, just domain models for my application. They can return outputs or, maybe return nothing as we do in this case. There's this same run async method where I'm able to do something. This is just a simple demo, so we're just logging a message in this case. Activities can also participate in dependency injection. So if I need access to the logger for ASP.NET, I can get that in the class constructor here. If I want to bind to the Dapr client, maybe I want to do some service invocation or publish to PubSub, I can also bind to the Dapr client and sort of use that inside of my business logic here as well. So anyways, back to the workflow. What this one's basically doing is we're notifying that we've received an order. We're going to call into a reserve inventory activity to sort of simulate the reservation of whatever it is these are ordered. We pass in a request ID, the name of the order, and then the quantity of the item that we want to get. We could check to see, did this particular activity return something called an inventory result? Again, this is just domain business model that we have here, which has a success flag. If we fail to do the reservation, then we can sort of return a result that says the processing failed because we had insufficient inventory. But assuming it succeeded, which it will, because if we look at the definition of this, all it's really doing is logging a message, sleeping for a couple of seconds, and returning true. So when that happens, we're going to move on to the next step, which is processing a payment. Again, this is just a very simple piece of code that sort of delays and writes some log information. And then the last thing we're going to do is call that notify activity again, saying that the order was processed successfully, and then return a result. So that is the order processing workflow. There are some rules for how you write these. As I mentioned, we write most of the logic that does things like I/O and interacting with systems inside of activities, whereas the workflow method is just for orchestrating those activities. And this is important because of some details about how these workflows execute. Because in fact, well, I won't get into too many details in this call just for the sake of time, but something that you'll want to take a look at our documentation for if you're not familiar with these types of replay-based workflow systems. Okay, so with that, why don't I jump back into the main structure? So I showed you the workflow, I showed you the activities that the workflow can schedule. And then the last two parts are we've added a couple of HTTP APIs, one for submitting a new order and one for checking the status of an existing order. And basically what we do in those is we take the order payload details from the body of the post request. In this case, we happen to be binding to a workflow engine client. You could also bind to a Dapr client if you wanted to sort of start new workflows. But we're basically just generating a random order ID, and then we're calling this API to schedule a new instance of this order processing workflow, passing in an ID that we want to use and the input payload that we got from the request. And then we're just going to return a 202 with a location header saying, here's the URL that you can use to get more information. So if you want to implement, say, the async HTTP polling pattern, you can do that really easily. And then the API for polling the status of the workflow, again, that binds to one of these workflow clients. We can say, hey, give me the workflow state. I can check to see, does that state actually exist? And I can maybe return some information about what its current state is. So with that, why don't I go ahead and run this application? So first thing I'm going to do is I'm going to switch over to here, and I'm going to start up an instance of Dapr. I'm using Dapr D directly in this case, but you would normally use just the Dapr run command for this. I apologize, this is my development machine, and hopefully I didn't break anything. But so Dapr is started up. Now I'm going to go back to Visual Studio. In this case, I'm just going to hit F5 to start this workflow application. And then it's going to open up this console window. And then if we switch back over to Dapr, one thing that we'll notice is that after I started my application, this workflow engine running inside of Dapr has started. And so now it's ready to start processing workflows. And so if I go back, actually in this case, what I'm going to do is I'm going to switch over to this console window. I'm going to send a curl request to that order's URL, and I'm going to send in an order payload. I'm going to order some paper clips, the really expensive ones, even for just a single paper clip. So we go ahead and send that. We get an accepted result, and we can see that, okay, something's happening over here on the Dapr side. If we take a look at the workflow app, we'll also see that those activities, we received the order, so we're seeing those activities, the notify, the reserve inventory, the process payment, all of those logs, and we see that the order was processed successfully. So if we then go ahead and take this, and I'm going to use a slightly different tool to send a quick HTTP request to that get endpoint, we're able to see that the order was completed, it was successfully processed, and even have some details of the workflow that we started. So again, this is just using the workflow engine built inside of Dapr and writing that simple ASP.NET application. Let's see, the other thing that I'll show just really quick is it is possible to use the Dapr HTTP interface to do the same thing. So if I wanted to start a similar workflow just using the API, I could do that as well. I'm going to go ahead and just send a request there using localhost, and then this is an alpha release, so be mindful of the URL here. The component name is just Dapr because this is the Dapr workflow engine, and you can see that another workflow has run to completion. So that works great as well. Last thing that I'll try to squeeze in here before I hand this over is let's see if we can do sort of a reliability, durability demo. So what I'm going to do is I'm going to start a new instance of this workflow. Let's see, what am I looking at here? That's not the right window. Sorry, this part I didn't have quite as much time to practice beforehand. Busy coding. Okay, so I'm going to send a new request for another order of paper clips. But this time what I'm going to do is I'm going to start that workflow, and then I'm going to immediately tear down the application to sort of simulate a crash. So I go ahead and submit that. Now I'm going to quickly switch over to this. I'm going to hit this garbage button, which basically kills Dapr. I'm going to go ahead and kill this application as well. And then what we should see is that, oh gosh, I had the thing paused, but I'm going to go ahead and start up the app again. And then I'm going to go ahead and let's see, let's go back to this window. I'm going to open up a new console here, restart Dapr. And then what's going to happen behind the scenes is that, we're trying to connect. We finally reconnect and reestablish the connection. And then what's going to happen is that the workflow picks up where it left off right away. And so you can see right here that it starts with processing the payment, started and then succeeded, and then the workflow was able to complete. So the initial steps, which were, sort of doing the inventory management and the reserve notification, that had already happened before I crashed it. And so we didn't run that again. We only picked up where we left off. So that's going to be a feature of workflows, is that if you happen to experience an unexpected failure and the app restarts, we're able to sort of pick up where we left off and continue the workflow to completion. So great. I'm glad I was able to get that working. I think that's pretty much what I had to show for this demo today. Again, this is all going to be part of v1.10, which is coming up. We're just doing the last stabilization pieces right now, getting this ready to go. So with that, I guess I'll stop sharing.
I think that's excellent, Chris. Thanks for an amazing overview. You had some great questions inside there. I think you answered one of the questions, which was about restarting on the failure, which you showed as part of the demo. I think that was one of the ones that Peter asked.
Awesome.
This is pretty awesome. So, just to kind of be clear, there will be other types of workflow engines you can also plug in as components as well. Is that right?
That's right. So that's the external workflow engines that'll work with our the workflow management APIs. As I mentioned, Temporal is going to be one of them that we support. We are looking forward to supporting a bunch more in the future, such as Azure Logic Apps. Maybe we can do the AWS Simple Workflow Service, and lots of others, open source ones too, that we want to consider.
So let's open up for a few questions. Anyone would like to ask any questions of workflows and Chris?
I would like to comment. Hey, Chris, this is your own. I think this has been an amazing demo. We've been working on this for a long while. There's too many things I love about this to be able to cover in one call, but I'll just briefly mention three. I think, one really important aspect to this is that you get a really powerful programming model when you pair up all of the Dapr APIs with this opinionated programming model. So, I've watched a talk from KubeCon from 8 years ago by Gabe Monroy. We worked together. And one of the first things he started off with in that talk, when he presented some of the stuff they're working on at the time, was no application is an island, right? Like, applications need configuration, they need pub sub, they need eventing, they need secret management, and they also need opinionated programming models such as this. So really, when you pair up Dapr to give developers all of these primitives and such opinionated programming models, you get really this one-stop shop for microservices, and this really excites me. The other thing, outside of the built-in programming model that Dapr has for workflows, is the ability to start other workflow engines and create a single consistent management API layer around Temporal or other workflow engines. And that'll really help make those Dapr APIs like the de facto management layer for workflows. And we'll start looking into pushing that into CNCF as well, because as you mentioned, there's the CNCF workflow spec that's coalescing around that. And yeah, this is all quite awesome. And one last thing is, I really love how this plays well into the architecture of Dapr, which is RPC focused, because 3 weeks ago, I was able to create a very bare bones JavaScript SDK and actually run Dapr workflows in the browser. And I'm actually working on a demo to be able to show that in an upcoming community call. So the implementation end-to-end has played so well with the Dapr architecture. And I think users are going to find this to be a very natural fit if they're existing Dapr users or if they're new to Dapr. So great work.
Yeah, thank you, Yarn, for those comments. And yeah, wholeheartedly agree with all the things you said. Thank you for adding some of that context.
Peter, it looks like you have your question still that you might want to answer. Do you want to ask it, or? If not, we can move on. All right.
Yeah, sorry, I was just looking for my microphone button. Can you hear me okay?
Yes, we can hear you. Go ahead.
Right, so imagine there's one method that's being executed, and I saw that one method had a number of awaits in there where it was calling out to other parts of Dapr. My question is when the server crashes and then comes back up and that method is re-executed, as it comes through the steps in the method, will it execute all of them again? Or will it say, for example, the first one that had already executed, it will retrieve a cached result rather than executing it again? And then the next one, it will retrieve a cached result from when it ran it last time. And then the next await, it hadn't executed it last time, so it will actually run that one. I don't know if that question's clear or not.
Yeah, I think I understand what you're asking. And that's what I was trying to demonstrate a little bit. I didn't go into as much detail as you did, but with the crash example where I crashed the process, I brought it back up and sort of showed that when it came up, we only executed the actions that had not yet completed for the workflow. So to answer your question, yes, it's pretty much exactly as you described. We will cache, we will durably cache the results of any of those previous tasks so that when we do sort of restart and replay that workflow, we just fetch the value from the cache so that we don't have to actually call that same task a second time.
Yes, excellent. Brilliant. Thank you very much for answering that.
Excellent. All right. Well, with that, thank you, Chris. Amazing demo workflow. Excited to see it in 110. And so what we'll do now is we'll move on to Philip.
All right, let me go ahead and share my screen. Okay, let me know if that doesn't show up in a moment.
We can see it.
Okay, great. So hi, I'm Phil Hoff. I'm a newish member of the Dapr team, but I've been familiar with Dapr since its beginning. I helped develop the Dapr extension for VS Code, for example. One of the things I want to talk to you all today about is building pluggable components in .NET specifically. So pluggable components has been covered in previous sessions, as Mark mentioned. For those that aren't that familiar with pluggable components, I'll just give a super brief overview. Pluggable components are the idea that we want to, or Dapr wants to enable component development without necessarily having to integrate with the Dapr sidecar. Currently, all of the components are built into the Dapr sidecar. That means two things, at least. One is that it needs to be written in Go, which not every developer may be familiar with if they want to have their own custom component that doesn't exist yet. And the second thing is that it needs to be integrated into the Dapr sidecar, which means it needs to be forked, PRs created, committed into the main branch, and then actually released with a Dapr release. And that timeline doesn't necessarily work for everyone. And so pluggable components allows a little bit more flexibility, both in the platform that you use to develop components with, as well as the timelines. For example, you don't even have to release your component publicly. You can have a private component that reaches out to some private store that you need for your applications. Pluggable components are just an additional sidecar that exposes a gRPC service. And it does so in a very particular way for use by Dapr. It actually exposes it not via HTTP, but through a Unix domain socket on a shared volume. I won't go into the details about that, but you can look that up in the documentation. And the services that are exposed correspond to the typical Dapr building blocks. So there's state store, there's pub sub, input and output bindings. There'll be preview SDKs shipping alongside Dapr 1.10 for Go, Java, and .NET, which is what I'm here to talk about today. All right, so with respect to .NET pluggable components, in developing the SDK, we had a series of goals. One is to sort of simplify the writing of pluggable components, right? And that's to build an abstraction on top of all of the gRPC protocol, service, client APIs, and so on, so that you can just focus on .NET and writing and implementing your component, not having to worry about a lot of the underlying details. Also intended to build for the latest .NET runtime, as well as being very familiar with, or be familiar to ASP.NET developers. So if you're an ASP.NET developer today, developing a pluggable component will feel very familiar, and you should be comfortable in doing so. And then also to mesh well with the standard .NET developers workflow, so that you can both implement, build, and test your pluggable component within the same context that you're building and testing your larger application. So as far as the SDK goes, it's built on .NET 6, so you can take advantage of all of the latest .NET runtime features and libraries. It's based on ASP.NET Web Host, so it's running on top of Kestrel. Will have SDKs. There'll be 2 packages published as NuGet packages that you can pull into your application. And then as far as deployment goes, it's deployed in the same way as any other pluggable component. So it's deployed as a Docker container that just happens to be based on a .NET runtime. All right. So as far as the architecture goes, so we've talked a little bit about Unix domain sockets and how pluggable components work, but we'll see we have the application. Your normal application is talking to a Dapr sidecar in the normal way, gRPC or HTTP. To talk to your .NET pluggable component, this is the separate sidecar that I mentioned that's running, exposing gRPC services over Unix domain socket, and that's what the Dapr sidecar used to communicate with that component. So a single .NET pluggable component instance can actually support multiple services, right? So it's not necessarily a one-to-one relationship. You can host a pub sub, a state store, and an input and output binding. And in fact, you can actually host multiples of those if you want, by simply having multiple, in the .NET SDK, they're called services. Each are sort of tied to a particular domain, Unix domain socket. So you can have as many sockets as you need, and then expose as many services from those sockets as you need of individual types. So you can, for example, expose 2 pub sub components from the same socket, but you could expose 2 pub sub components from 2 separate sockets. So you can sort of mix and match and arrange your pluggable component in whatever way makes the most sense for your particular use, right? If you want to have a separate pluggable component instance and container for each individual pluggable component that you're writing, that'd be fine. Or if they're related, maybe it makes sense to all bundle them together in a single container, and then have a single instance. All right, so let's actually take a look at an implementation. So I'm assuming you can all still see my screen. If you can't, let me know. But really, creating a component comes down to implementing one of a set of base interfaces for pluggable components. So I'm going to show you a very simple implementation of a state store. It's just really implementing iStateStore, right? And that's just at a minimum 4 methods, right? There's the init method. This init method is what gives you your metadata that's configured in your Dapr configuration file for that component. If you have any configuration settings and so on that matters to your component, and then implementing a couple of methods. So for the state store, the basic one is set and get. So this is just an in-memory state store, so it's just storing it to a dictionary. We'll look at the set implementation, right? Very basic, right? The request stores all of the information that's coming from Dapr, the key, the value to set, metadata, content type, etc. You can do with that what you will. And then the opposite, or the corresponding get call, which is what key you want to get. You get it from the state store or whatever's backing your pluggable component, and then just returning the result in a state store response if there is one. And that's really it. And similarly for pub sub, for input and output bindings, you would expect to find a very similar, very simplified .NET interface that you need to implement. All right, so what does that look like in terms of setting up? So you'll see the actual setup of your pluggable component, if you're familiar with ASP.NET, is very similar. You create a Dapr pluggable components application. You register a service, and as I mentioned before, the service is what's sort of tied to a specific Unix domain socket. So this is the name of the socket in memory store. And then you register one or more services, one or more components on that service. So in this case, we're registering a state store, we give it the type. Now that type will be instantiated whenever that component gets a request for that state store, and call its methods, and then run. So very the same structures you'd expect for an ASP.NET application. You can do the same kinds of things with respect to dependency injection, logging, configuration. You can use all of those same libraries to configure those things as you would in any other ASP.NET application. All right, so let's go ahead and start that up. We'll start up the application or the pluggable component. You can see it's actually listening on that Unix domain socket. and we'll go to our back end, and we'll take a look at the back end. The back end is just simply a harness for testing the pluggable component. There's nothing special about it. It has two methods or two endpoints, one to put a key into a store and one to get that key back from the store. And you can see that we're using the Dapr client SDK to call get state async and save state async. So nothing particularly complicated about that. We'll go ahead and start that up using Dapr. So that will get our Dapr sidecar. That's now running. So we can go and we know what that's running on, what port that's running on. So let's go ahead and add a key. So we can do send a request. Now we've actually stored a value in that pluggable component. We can go back to our log output and we can see that, yep, it did get in fact, a bulk set request. We actually will, if you don't implement bulk set and the bulk APIs directly in your pluggable component, the SDK will actually implement it for you so that you don't have to do that if you don't want to. And let's go get that value back. So here's our value that we got back from the state store. You can see our pluggable component got the request for the key. And so that's just the most basic implementation. One thing that I will cover is how to configure a pluggable component. This is covered in the Dapr docs today, but it's like how you configure in almost any other component with Dapr. The main thing is that for the type, you'd say the type of component. In this case, it's a state store, and then the name of the socket that Dapr should look for to connect to that pluggable component. And that's basically it. So that's the main component, and I think I have a little bit of time. So one other thing that I wanted to mention was that we can easily make development of pluggable components part of our sort of normal development workflow. So I can start up using my own orchestration tool that I'm familiar with. So I can start both my application and the state store or the pluggable component at the same time. I can do things like, there's my in-memory store. I can attach a process to it. Now I'm actually running in the debugger. And let's see if I can go up here and see.
So Philip,
yes,
you could please show again where you expose or define the socket in the component?
In the component, that'd be fine. So here's my when I register the service, you can see here's where I name the socket, and there's some, flexibility in how that socket is named, where it's placed, and so on. But this is the basic implementation. Is you just name it here, and you can see that matches the configuration. Does that answer your question?
Yeah, it answered it.
Okay. All right. So let me open up the portal so I can get the name of where my backend is running. That's actually what I want. I'll go back to here, and I want to go back to my page. Let's put that up. So I happen to be using Thai, and that adds a dynamic port for all the applications. So now let's see if I send my request, and there I am. Now I'm actually debugging my pluggable component in the same way that I debug any other .NET application. So I can let that go through. And then I could go back to test and get that value back out. And you can see here, I can see my requests and so on and so forth. There's a key that I'm expecting to get, any metadata that might be passed alongside. And that's that. So that's what I wanted to show. And I think that's about all my time. So let me know if you have any other questions, comments, feedback, and so on.
Thanks, Phil. That's amazing. That's going to make it a lot easier for people to build these pluggable components. And you said there was .NET, Java, and Go SDKs for this in the upcoming 1.10 release, yes?
Correct.
Yeah, I've only looked at the Go SDK, but I was able to start writing a pluggable component in less than 5 minutes with it. It's a really good experience. So thank you.
Excellent. Okay, if there aren't any more questions, if there are any questions for Phil here to ask. If not, we will
It
move.
looks like there was one about whether there'll be a simple .NET example of pluggable components in the 1.10 release. The .NET SDK repo will have samples for every component type, so state store, pub sub, and bindings. I think the state store is a simple in-memory state store. The pub sub is a implementation against Azure Storage Queues as a pub sub component, which doesn't exist in Dapr today. And then bindings is a implementation of a input and output binding for Discord.
Oh, cool. That's gonna be good.
I think those are the only questions I saw.
Okay. Well, thank you. Spend some time playing with pluggable components. Let us now move on now to Mukundan and to talk about the multi-app run. So Mukundan, over to you.
Hello. Yep. Hello.
We can hear you.
Yep. Hey, I'm Mukundan Sundararajan. I am here to talk about the Dapr multi-app run feature. So let me just quickly share my screen. Are you able to see my screen? I hope so.
Yes.
So yeah. So let's see how we can launch multiple apps on the development machine, right? So let's go over the Dapr run overview as to what's happening right now. So when you develop multiple applications using Dapr, so to run each and every app, you'll be opening up a new shell. You'll be taking care of all the configuration flags and all of those tweaks that are allowed and offered via the Dapr run CLI command. And you'll then be starting each of those apps in different shells. You'll be running Dapr run for all of those, which then starts the app and the associated Dapr process internally for during development, right? So these are all the things that you'll be doing when you want to develop multiple services with Dapr locally, right? And there are literally multiple different configuration flags that are provided for the run command. Like for example, you can set the Unix domain socket, you can set the application health check-in point, you can set HTTP port, gRPC port, you can set the read buffer size, and so on and so forth. There's a lot of flags that are there. So that internally, what happens is that actually is a hassle when you're going to start developing multiple apps and you want to quickly start a couple of apps in your development environment, and you would have to basically have multiple shells open. You would have to then run those commands and so on and so forth, right? So the intent of this feature is to basically allow users to run multiple apps from a single Dapr run command. So that is the intent of this multi-app run feature. So let me go over this feature as a whole. So if you want to see the proposal, you can see the proposal here in the Dapr proposals repo, which was accepted. So essentially running multiple apps with Dapr sidecars. So you can go over the whole proposal here, right? And the main things that this feature introduces, right? So the first one is a single YAML configuration template, which can then be used to configure multiple apps that can be run alongside a Dapr sidecar, alongside with the Dapr sidecar instance, right? So for each app, a Dapr sidecar process will also be started. So you will have the ability to basically configure a single template file, and from there you'll be able to start multiple apps with a single command, right? And then this proposal also introduces a local folder organizational structure, right? So what I mean by this is, by default, when Dapr initializes, when you run the Dapr init command, it then in Windows in the user profile directory, or in Mac and Linux in the home directory in the .dapr folder, you have the default components created in the components folder, and then a config file is created there. So following a similar structure, what we are defining for this feature specifically, which will then be added to Dapr Run in future releases. But for this feature, what we are developing is essentially or introducing here is you can basically create a .dapr folder inside your own app. And when you run the template, you can basically say it'll basically look for the resources or the components in the locally defined .dapr folder, which will have the most precedence. And if you have defined it in the template file, that will have the most precedence, followed by the local .dapr folder, and then followed by the global .dapr folder that's there in the home folder and so on. Right? I'll talk about this a bit more with the template as an example. Right? So apart from that, what we wanted for this feature was for it to be an extension of the Dapr Run command and basically try to mimic the existing Dapr Run functionality in this feature also. Right? So the initial alpha release is currently slated for 1.10 with the support in Linux and macOS, and Windows we are planning for the next future releases of Dapr. Right? So the template. So what am I talking about when I talk about a template? Right? Again, another YAML file, but again, this is one YAML file that can be used to define multiple apps, and essentially the resources associated with those apps, any environment variables associated with those apps for any of the local development environment that you want. Right? So in this case, if you see here, you have a common section here, and that common section you can define any resources part that you want that points to the resources that you want the app to use, or a config file which is common across all apps for this particular run template, or you can define some common environment variables that you want to use. Right. So all of these will be applied across all the apps in the app section. Right. And each of these variables can then be overridden again here. So all of these are optional. All three are optional in the comment section. The whole comment section is optional. So next, you define an app section, and essentially that's a list of the apps that you want to basically run. Right. So the main things that are mandatory here is actually the app.part. Right. That's the main mandatory field that's required. So any app will actually have an app directory path associated with it. And then if it exports an app port, you can have the app port here. If it exposes or uses a particular HTTP port, you can specify the HTTP port here, or it will be automatically injected into the app as an environment variable, which you can then consume. Right? And the command again that you want to run the app, like for example, in this case, it's a go command that I'm just running. So you can just do go run app.go, or you can omit the command directly, and that will essentially then only have Dapr sidecar started up, right? That is similar to how you just run Dapr Run right now, and only the empty sidecar starts it with no application. So if you don't have a command here, essentially only a Dapr sidecar will start, right? So that is why command is also not mandatory here. And again, if you see here, app ID for the first one is not mandatory. Again, if you don't have the app ID, so what will happen is the directory name will be used as the app ID automatically. Right. So instead of that, if you can have the app ID if you want, and you can define whatever environment variable that you want to be used, and so on. So this is one thing that can be done here. And from here, when you do a normal Dapr run, you'll be seeing that both the application logs and the Dapr logs will be shown in the same shell output. And obviously, when we are going to run multiple apps, we can't crowd the standard out with all of those logs. So what is done is if there is not a .dapr folder in the local app directory, a .dapr folder will be created with a logs directory in it, and the logs will be written as two different logs, one for the app and one for Dapr, right? So that is what is present here, right? From here, let me go and quickly show a demo of this, right? So this is the example template that you have here. But the example that I'm going to show is the distributed calculator application that we have in the Quick Start 3. So each of these apps are in completely different languages, and we essentially have 4 different apps, each for an operation, and 1 front-end app here. Okay, so we have 5 apps that are currently shown here, and each of them you can basically define the app path and app ID. Again, here app ID is done for every application because we need to have a specific app ID, right? But again, that can be omitted, and so on and so forth. So this is kind of how you will have the template defined for running all those applications. And basically what I can do is I can just do Dapr CLI or Dapr and then run Dapr, right? So you can pass in either the folder. If you pass in the folder, it will default to dapr.yaml. It will try to find the file called dapr.yaml. If it's not able to find it, it will error out. Or you can pass in the actual file itself, right? So in this case, I'm going to default to the folder. So what will happen is it will then say, okay, fine, validating this, starting the app called add app, and then it will just say what the Dapr process started with, what's the HTTP port, what's the gRPC port, if it's injected, and so on. So if you see here, all the gRPC port values are currently injected automatically into the app, and the HTTP port is currently defined by the configuration, right? So you have the add app, divide app, multiply app, and all of those apps are currently defined and started. And you can see the logs directly, it will automatically write to the default logs.dapr local logs directly, okay? So if I go back and show you what's happening here, so for example, you can see the Python. In this case, you'll basically have a logs directory which shows up with the Dapr log, and essentially it doesn't have an app log yet, complete app log. Okay, so in this case, let's go back and show the working of the app. So what I can do is, this is the front end that you have for this. So let's say I'm just going to multiply again, then do some subtraction, and then some division by 2, let's say, with that example, right? So what's going to happen here is for each of those applications, you can basically see that, okay, fine, you have got a 5x6 for multiplication, and then for node, again, you have dividing by, the node app is the division app, and currently you are saying dividing by whatever the app log is, right? That will be output here automatically in the app.log file, right? And this, again, you can use the same thing. So it has currently started with multiple applications, right? So you can basically see what are all the applications started using the normal Dapr list command, right? And you can then, if you want, you can basically stop the commands using Dapr stop, or you can also stop it using stop it by inputting the run file directly, right? So when you stop it by inputting the run file directly, what happens is it stops all the apps, right? So that is pretty much what I wanted to show in this demo. So let me stop my share for now. If you have any questions, please let me know. I'll take an answer there. Right?
George just asked to clarify, this will be in the 1.10 release that's upcoming.
Yes, yes. This will be monthly release for Linux and Mac. Yes.
And there was a question, a remark from Yaron saying that is the first YAML that uses a snake case. We need we're going to discuss this offline. We're going to see if we can if we should change it to camel case, should be aligned with the rest of Dapr.
Yeah, we can discuss this offline, but yeah.
But it's fantastic. What you can now do is start and multiple applications at the same time, and then just if I stop one of them and then rerun it again, does it just start the one that I stopped?
No, as of right now, for particular alpha release. Currently, you can only start all the apps, but you can stop individual apps if you want, or you can stop all the apps. So that is the current implementation. But yes, in future we can look at starting only a particular application if all the other applications are started. So yeah.
Okay, great for that.
That is also one point, like, I don't know if it was mentioned, but when you don't specify the app ID in the YAML, Mukundan, can you confirm that the app ID is inferred by the folder name?
Yes, it is, right? So let me share my screen again, right? So in this case, if I don't give the app ID here, right? So if you see the dapr.yaml file, and for now, for this example, I'm basically giving app ID because I need a specific app ID. But if I don't give it, essentially it's going to be inferred from the app directory path, right? The folder name of the app directory, right?
And for the Dapr HTTP port, if you don't specify one,
Yep.
the one is picked up, right?
Yes, it will be injected, and you can then consume it as an environment variable in your application.
Okay. Okay.
Yeah, I think it's important we have examples for the scenarios where you don't specify the individual ports and when we inject them.
Yep.
Yeah. The only required attributes here on for each app is the folder,
Yep.
port if the app is listening on a port, and the command.
Yep. Command again is not required, right? You can still have without a command, and that will just start playing Dapr. Right?
Oh yeah, if of course, if you want to run your actual app, yes, you need the command. But if not, yes.
Yep.
Okay, that makes sense.
Yep.
Now, I'm not saying we need to do this, but by any stretch of the imagination. But if we wanted to, we could theoretically launch the process from the command prompt, then get the port that's being used in the OS and use that as the app port, maybe just to remove the need to put in an app port. Would that work?
But we will need the we will also need to do some smartness to understand which protocol the port is listening on, right? Is if it's gRPC or HTTP.
Yeah. Yep.
It is possible. You just need to add some more.
Yeah, I'm not sure all this trouble is worth it, just to remove that app port, but maybe, because I'm kind of allergic to putting app ports everywhere, so.
I hate it. Yeah. The problem is when the app listens to multiple ports, and then you have to guess which one it is.
Yeah.
Okay, well, thank you for all our presenters today. The great thing is all of these things are coming out in 1.10 release. The good thing is all of them have the chance for you to influence them still. They're still in 1.10 release in preview and the ability to kind of give your feedback and be changed in future releases. So with that, I'm going to say thank you to all our presenters today, and look forward to you on the next call, which will be in a couple of weeks' time, where we'll spend some more time on the 1.10 release and looking at some of the other features inside that. And if you have any particular requests that you'd like to see for demos or things that you'd like to cover, post them in the issue that we have inside the community issue for the community meeting. So with that, I'd like to say thank you.
Thanks, everyone.